Hello everyone. Today we are going to be looking at statistical inferences and we'll be applying the hypothesis testing on proportions. Once again, we are going to be doing a little recap of the things we have done earlier, and we learn about the hypothesis test for population proportions, look at the formulas and some procedures, and then do some examples. So remember, significance test is basically used to make inferences to decide whether some claim or hypothesis about a population is plausible. And we use data to summarize this evidence, with the most important thing that the data which we are using is randomly generated. Remember, the hypothesis is of two types: the null hypothesis and the alternative hypothesis. The null hypothesis is we assume always is going to be true. The alternative hypothesis is challenging the status quo. Now, how do we write it down? That's the main important part. The null hypothesis is basically the parameter, which can be proportion or means, equals the hypothesized value. The most important part is the parameter and the equal sign. Now, there are three alternative forms for this alternative hypothesis. Which one is that, like, parameter is greater than hypothesized value? That means we're looking at a right-tailed test. The parameter is strictly less than the hypothesized value. That means we're looking at a left-tailed test. Both of them are one-sided tests, by the way. And another alternative hypothesis is when the parameter is not equal to the hypothesized value. That means we're looking at a two-sided test. So let's look at one example here. The proportion of all Canadian students who are regular smokers is less than 0.24, the value it was 10 years ago. What would be the null and the alternative hypothesis? Now remember, the first thing is we have in the null and the alternative, we have to have a parameter. The parameter here is proportion. That means we will have P as it is null equal to, and alternative we will have P at this point. Now we have to make the decision, what is that numerical value? It says the proportion of these Canadian students who are regular smokers is less than. That means we are looking at alternative hypothesis than 0.24. That's the value we're looking at, 0.24. And for the alternative hypothesis, P is less than 0.24. Okay, so now we have to do our analysis. So when we're doing an analysis, in other words, we are carrying a test of the null versus the alternative hypothesis. In other words, do we reject or do we accept, or do we fail to reject the null hypothesis? And so here, the way we look at it is, if we have a sample which strongly suggests that the null hypothesis is false, then definitely we are going to be going in favor of the alternative hypothesis. But if we find a sample which does not provide such an evidence, then the null hypothesis will not be rejected. And in order to do these, we need to have a test statistics and a p-value. Remember, test statistics is the quantity on which the conclusion to reject or fail to reject is based. And the p-value is the conditional probability. It is the probability which tells us whether the observed statistics is unusual given the null hypothesis. Okay, and the way we make our analysis is we reject the null hypothesis if the p-value is less than or greater than equal to alpha, and we fail to reject null hypothesis if the p-value is strictly greater than alpha. The alpha here, guys, I'm talking about is the significance level. Okay, So now we are going to be looking at hypothesis testing about proportions. In other words, what would we need, the assumptions, what is the test statistics, and how do we find the p-values. Okay, so that's what we are going to be now working on, the steps in hypothesis testing. The first thing we need in our step is the population characteristic we are looking for. The population characteristic, which is the parameter. Then we will look at the assumptions. Then the next step, we state the hypothesis. In other words, what's the null and the alternative hypothesis. We select the significance level alpha for the test. Now, you do not have to worry about this. It will be given to you. And then we apply the test statistics to be used depending upon the population characteristic. And we have to make sure that the assumptions are valid. And after that, we find the p-value, which is associated with the observed value of the test statistics. Now, these guys are based upon the sample data we have. And then finally, we make the conclusion. So, the hypothesis test for population proportions, what are the necessary assumptions? Now, first of all, it has to be a simple random sampling, and then the number of sample data points times the hypothesized value is greater than or equal to 15, as well as n times 1 minus the hypothesized value is greater than or equal to 50. Then we write down or state the null and the alternative hypothesis. Remember, null is very simple. It is p equals something. Whereas the alternative hypothesis can have 3 different forms. P is strictly greater than, less than, or not equal to p0. Now, once these assumptions have been satisfied, we take into account the significance level. And as I have said, it will be given to you. You do not have to worry about it. Now, to compute the test statistics, for proportions, we use the z value here. Z is given by p hat, that is the one we get from our sample data set, minus p0, square root of p0, 1 minus p0, the whole expression divided by n. Then we compute the p-value. Okay, the probability that a standard normal random variable is as extreme as the z. That is the test statistic here for us. We will reject the null hypothesis if the p-value is less than or equal to alpha. Now, when we are performing these tests on population proportion, we have to keep in mind, because it's a z test we are applying, that we either have a normal distribution. If we do not have a normal distribution, then n is large enough to make it approximately normal distribution. Those are the very important scenarios. Now let's look at some examples. Let P, the population proportion, denote the proportion of grocery store customers that use the store's club card. For a large sample Z test of the null hypothesis versus the alternative hypothesis, we would like to find the p-value associated with each of the given values of the test statistics. So in other words, we are given the Z value, okay? And we would just like to find what are the p-values of it. So when we say Z is 1.40, so we like to find what is the p-value of Z greater than or equal to 1.40. This is the p-value, guys. Remember, this one is the p-value. Now, that means it is the normal CDF, and you guys all know how to do it because it is Z is greater than or equal to. Remember, this is the way you're looking at. Your P is 0.5 and the Z hypothesis is 1.4. That means we are somewhere Z is greater than or equal to 1.4. Now remember, this is 0.5 is the same as 0 because in the Z it is transported to 0. So 1.4 somewhere is going to be here. We like to find out what is the p-value in this scenario. Because Z is the one which has a normal distribution. It's a standard normal distribution. That means 0.5, that is the P0, is actually the mean of that function. So the normal CDF 1.4999001, we get 0.0808. Now, if the z-test was 0.93, then what would be the p-value? P when z is greater than or equal to 0.93. We again apply the normal CDF. You guys, I hope, remember 0.93999, 0 and 1, 0.1762. So let me just do one of them for you because we have done it so many times, but still. Okay, to find the p-value when z is greater than or equal to 0.93, you go to second inverse, you do the normal CDF, take the cursor to number 2, press enter. Now z is greater than, that means this is the value 0.93. The upper value is 999. And this remains the same because we are applying the z-test, guys. So we do the paste, enter, enter. So you get 0.1761. Okay. Okay. Let's look at an example. We like to practice our assumptions. Is the z-test appropriate or not? Assuming a random sample from a large population, and we do not know what the distribution is, very important, for which the null and the alternate sample size is given. So this is the null hypothesis and the sample size. For the z-test to be appropriate, remember the n times p0 should be greater than or equal to 15, and n times 1 minus p0 should be greater than or equal to 15. And it has to be a simple random sample. And so it is a large population. When it is a large population and greater than or equal to 25, that means it is an approximate normal distribution. Okay, but then these two have to be also satisfied. So when we plug in the values, 25 times 0.2, which is 5, which is not greater than 15. So we cannot apply this z-test here. On the other hand, if my p is 0.8 and n is 100, so when you do n times p0, 80, definitely greater than 15. And also 100 times, this is 1 minus 0.8, that gives me 20. Again, this is strictly greater than or equal to 15. And hence, this one is the appropriate one to apply the z-test. Now, guys, we're going to look at very specific examples and learn how to apply the hypothesis testing by reading the problem and doing all the steps. Okay, here's the first problem. In December 2005, a county-wide water conservation was conducted in a particular California county. In January of 2006, a random sample of 500 homes was taken. Water usage was recorded for each of this home in the sample. And it was found that 44% of these houses had reduced water consumption. Now, the county supervisors wanted to know whether the data supported the claim that fewer than half the households in the county had reduced water consumption using 0.01 significance level. Okay, now remember, guys, when we read this problem, we're thinking, the word is like, what are we trying to do? So, when you read this, you have to fish for the main thing. The thing is claims. Do you see this one? The moment you see the word claim, oh, we are doing hypothesis testing. That's the first thing to keep in mind. Okay, what are we claims? Like which parameter are we working? Then you look around and you do not see the word mean or average at all. And then you see there are percentages. Oh, that means we're looking at proportions. And also, when you read this problem, you will see that, they say 44% of the houses had reduced water consumption. So when you're looking at this one, so these are some giveaways. Oh, we're doing the population proportion here, the hypothesis testing for that. So over here, when we're looking around, so we need to know whether the assumptions are met, what is the alternative hypothesis and all that. So once again, we're going to read the problem And as I read the problem, I will tell you, oh, this is what is needed. This is what is needed, okay? So the first thing we have been able to make, it's a claim. That means hypothesis testing. And this 44% is giving me a clue that I'm doing proportions here. So you say, let P, the capital small p, be the true proportion of the households in the county with reduced water usage. So let's go back again, read it again. So it's in December of 2005, a county-wide water conservation was conducted. And in January of 2006, a random sample of 500 homes. Okay, that means that is my N, keep in mind. The number N is 500, okay. These randomly, so random sample means, oh, assumptions are being met. One of the assumptions, it has to be random sample. And water usage was recorded for each home in the sample. And it was found that 44% of these houses had reduced water consumption. Okay. Now, the county supervisors wanted to know whether the data supported the claim that fewer than half the households. So here's the clue of what kind the alternative would be. Fewer than half the households. Remember that. Half means 0.5. So this is a giveaway that we are given the alternative hypothesis as to be proportion fewer less than 0.5. Once you have got the alternative hypothesis, automatically you know what the null hypothesis would be. It will be P equals 0.5. Okay, the null model is not making any difference between the water conservation. It is only interested in the reduction of it. Now, clearly, when you see these two, null and the alternative hypothesis, it tells you, oh, the moment you look at the less than symbol, it's a left tail test, or a lower tail test, or a one tail test. Keep that in mind, okay? Now, are the assumptions met? The first assumption, yes, it is simple random sample. That has been met. There it is. The simple random sample, yes. N times P0 is 250 and N times 1 minus P0, which is again, N is what, 500, 1 minus P0 is again 0.5, is 250. Okay, so this model, we can say that the sampling distribution of the sample proportion is a normal model. Remember, we're going to apply the Z values, the Z scores and everything. So the sample distribution of the sample proportion has a normal distribution because N is so large. Now, thus the null model is a normal distribution. What is the mean? The mean is given to be the hypothesized value, 0.5, and a standard deviation of square root of P0, 1 minus P0 over N. If you so just remember this one. After that, you're just plugging in the formulas. You get the standard deviation to be 0.0224. Now, the observed proportion is P hat, that is, it said when they did the random sample, they found that 44% of the household. That means what is 44% of the household of 500 homes is 220. Okay, keep that in mind too. Then, once we have the observed, because you have to find the test statistics, it is Z equals the P hat. So that's how the Z values P hat minus P0 divided by the standard deviation. So this is the standard deviation, which gives me negative 2.68. So that means that the sample proportion lies 2.68 deviations below the mean. Now, the corresponding p-value. What's the corresponding p-value? The corresponding p-value is found by z less than equal to negative 2.68. Now, let me draw you the graph also. So you see when you draw this graph, here guys, my h sub naught, minus 2.68 is somewhere over here, and we're looking at this p-value. So when you plug it, this p-value is 0.0037. It's very small than the significance level. Because the p-value is very small, hence we are going to reject the null hypothesis. Okay, now that is going by step, just plugging in the formulas. What I've also done is I've given you another way. You can just use your calculators to do all the answers. So what you're going to do is I've written down all these steps and I'm going to show it to you here on the calculator. So what you're going to do is to find this. Now keep in mind these values, okay? So the values which I definitely need is, so first thing you have to do is you go click on second, okay? Let me just get this here. You click on second and stat. Not stat, sorry. Click on stat, sorry. Then when you click on stat, take the cursor to tests. Then you take the cursor to proposition Z test, the number 5. Press enter. Now here you're going to fill in the values, okay? The values which you guys are going to fill in is what the values we were having. So the values we need is P sub 0 first of all. Now remember P0 is 0.5. So 0.5. Now X, this X is the number of households that had reduced. That was 44% of 500. That is 220. Do not write 0.44. It will not work. It needs a number, guys. What is N? N is the sample size, which is 500. Now you're looking at proportion which is less than P0. Take your cursor over there, less than P0. Press enter. Now remember, you're going to do calculate, okay? Some of you may not even have the word color, blue or anything. Don't worry about that. You just take your cursor to calculate, press enter. Normally, you will see all the values which we had done by hand. You found the Z, that is the test statistics, and the p-value 0.00364, which is 0.0037. It automatically also gives you the observed test statistics, which was like the sample data 0.44. What we really need is the p-value. That's what you're looking at. Okay? So I've written down all these steps, guys, and the procedure, and that's what you do. It will make your life simple. Okay, and one more thing. When you're doing these problems, let me show you something. Your diagnostic has to be on. If it is not on, what you need to do is, because if it's not on, sometimes it may not give you answers. You need to do second and catalog, and then take your cursor to D. If it is not on, sometimes it doesn't work. Okay, there you go. You see this diagnostic on? So take your cursor here. Press enter, and after that, if there's no then your calculator will give you the answers. Okay. Okay. Now we're going to go and look at another example. So this example, I've done exactly the same thing as the previous one. But I would focus, when I want to solve it, I would be focusing more on using the calculator. And if you really want to go and look at each and every step, I have shown that step too. Okay. So here's the problem. Anyone who plays or watches has heard the term home field advantage. Now, teams tend to win more often when they play at home, or do they? Well, in 2005, Major League Baseball season, there were 20-40 regular season games. And it turns out that the home team won 1,306 of those 2,240 games, or around 58.30% of the time. Could this deviation from the 50% be explained from natural sampling variability? Or is there an evidence to suggest that there really is a home field advantage? At least in professional baseball. Do a hypothesis testing using a 0.05 significance level. Okay, So the first thing is we already told that we have to do hypothesis. Okay, great. And then we think, oh, I did not see the word mean or average. That means I'm doing proportions. Great. Then I need to know what is my null and the alternative. So let's read the one with the could this deviation. That's going to be the key. And the home tease. It says, could this deviation from 50% be explained from natural sampling, or is there an evidence to suggest that there really is a home field advantage? That means we're going to have more than, so that when you have a home field advantage, that means you're going to win more than 50% of the chance. That gives the answer, oh, this is the alternative hypothesis. Once we get the right alternative hypothesis, null hypothesis is just putting an equal sign there. Now, clearly, when you see the alternative hypothesis to have a greater than symbol, that means we are going to have a right-tailed test. And then we have to make the assumptions are true. It is random sampling. Great. Natural sampling tells us it's a simple random sample. Great. We get that out. And then we have to do the n times p0, and which also gives us 12,000. It's a big number. Good to go. So that means we can model the sampling distribution of the sample proportion with the normal model as the sample size is large. Now this null model, the null model we're going to talk about, that means, because you remember we're trying to test the null hypothesis, so that's why we call this null model. Okay, so the null model which we have has a mean of 0.5, standard deviation of this, all the math. The observed proportion is that 1306 wins out of the, 24-20 season games. We find the test statistics, basically plug in the values. Okay, once we plug in the values, we want to find the p-value. Remember, the p-value gives us the answer. So to do the p-value, we just plug in the values, z greater than or equal to this, normal CDF, and we get the answer. Clearly, it is very small than the significance level. It's in a like 4 times 7 times 10 to the power negative 5, or 0.4 zeros and a 4.7. Okay, so clearly the p-value is less than alpha, so we're going to reject. Which simply says that the true home proportion team win is not 50%, and that yes, there is a home field advantage. Because when we reject the null hypothesis, we are saying is that the alternative hypothesis, which is basically the winning thing, is true at the home. Okay, now as I said, when you want to do these problems, it is much more better to just click, 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 use the calculators, get your answers. So once again, click on Stat, Test, 1 Proportion Z Test, and make sure you're writing down the correct information. You need to make sure you write down the hypothesized value, which was 0.5. The X is the how many wins or the percentage of the wins, and the N is the number of samples. And what is the proportion? That means what is the alternative hypothesis? Once you do all this, this is the answer you get. This is exactly the same as what we got by doing it by hand. Much more easy to use our calculators to do the work. So one more example, guys, and we'll be done. Now here, this is the public policy of California, which reports that 71% of the people nationwide prefer to live in single-family homes. Now to determine whether the preference of Californians is constituent with the nationwide figures, a random sample of 2002 Californians were interviewed, and out of those, 1,682 said that they consider a single-family home the ideal one. Now, can we reasonably conclude that this proportion who prefer single-family home in California is different? You know, the word different means we're going to have an alternative hypothesis of a not equal to sign from the national figure. Different means either it can go up or down. That's the meaning of that. So we're going to do a hypothesis testing using a 0.01 significance level. So here, P is the true proportion of all Californians who prefer single-family home. We have the null hypothesis. Remember the hypothesized value? 71% of the people nationwide. So that is my P sub 0. And when you read the second last sentence saying, can we reasonably conclude that this proportions who prefer single family homes is different, that's a sure shot of saying, oh, the alternative hypothesis will have a not equal to sign. Remember, different means it can be more or it can be less. It can go either way. Okay. Now this, when you see the alternative hypothesis to have an equal, not equal to sign, that means we're dealing with a two-tailed test. In other words, we have this. There are two places where you will have the p-value. Okay. Once again, before we do, we need to make sure the assumptions are right. Yes, assumptions are right. Remember, simple random sampling was done. After that, we do n times p0, which is greater than 715. And clearly, the null model, you will find that is the alternative hypothesis, that's what basically it's saying, is a normal distribution because the sample size is large. Remember, what we are doing is we are trying to test the null hypothesis, whether it is acceptable or not acceptable by the claims which are being made by the alternative hypothesis. Okay, so you do find the observed proportion. Remember, this 0.84 is coming from, they said that how many people favored? They said 1682. So when you divide 1682 by 2002, you get 84% here. Then you find the test statistics and you get a sample proportion lies 12, it's way above. So remember, when you find the corresponding p-value here, remember it is twice, because remember the graph we created, this is what the graph is. Because it is different, it can be less than or it can be greater than the hypothesized value. This is H0. You're looking at the sampling distribution of this sample statistics. So this is the p-value, guys. And hence we have to have twice the area under the curve. Either I can have less than 12.87. So this is negative 12.87. And this is 12.87. This area, because remember our normal curves are symmetric, this area is the same as this area. So I'm going to write twice the area under the curve. And we get approximately a 0. Now, p-value is definitely less than the significance level, and hence we will reject the null hypothesis, and which simply says that the sample data provides convincing evidence that the proportion in California who prefer single family definitely differs from the nationwide proportion. Now, that was doing step by step, but as I said, you can use our calculators, plug in the right terms, you will get the same answer. Okay, so stats test 1 proportion z test, plug in the values for p0, x, and n, and this proportion, and then you will get the following answer. Now remember, your p-value is going to be this, which is approximately a 0 value. Okay, let me show you this over here. So in your calculators, go ahead to stat, take the cursor to test. Now you're going to do the 1 proportion z test, enter. Now this one, p0 is 0.71, enter. Now x was 1682, 1682, enter. The number of samples is 2002. The proportion is not equal to, so make sure that is enter. Don't worry about the colors or something. If you don't see that, that's okay. It's not a big deal. Go to calculate, press enter, and you see this value. This is so small. This p 1.08 e to the power negative 37. What simply it means is this, what I've written down, guys, here. When you see e to the power negative 37, it's this. That's the way it is written. Okay? And definitely it is very small. And 0 is definitely less than equal to 0.01. So we reject the null hypothesis. Thank you.